Oh, hey, didn't see you there.
Hey, Casey.
Hi.
Hey, Josh.
Hi.
Hey, Jacob.
Hey. Hey, Mackenzie.
Hi.
Today we're going to help you solve the 2017 AP Calculus AB free response question number 5.
For 0 is less than or equal to t, which is less than or equal to 8, when is particle p moving to the left? I gave you the equation for the position function for particle p, and it is so now that you have the derivative, in order to find when it's moving to the left, we first have to find the critical number, so we should set this to 0. So when you set it to 0, you get that t equals 1, and then you can check this by using the sign chart. And then, because it's asking when the particle t is moving to the left, therefore it's going to be going like I don't know how to say this! So particle p is moving left when the derivative is negative. So therefore, because x p prime of t is less than 0 when 0 is less than or equal to t, which is less than 1, and we know that 0 is on the left end of the domain because in the problem they gave you that the domain is 0 is less than or equal to t, which is less than or equal to 8, so it can be anything less than 0. And it can be anything greater than 1 because otherwise it would be increasing. Therefore, the particle is moving left for 0 is less than or equal to 2, which is less than or equal to 1. To conclude, particle p is moving left on the interval 0 is less than or equal to t, which is less than 1. One common mistake for part A of this problem is not taking the derivative correctly. So the original equation is x p of t equals the natural log of t squared minus 2t plus 10. And in order to take the derivative correctly, you put 1 over that whole quantity, so t squared minus 2t plus 10. But then you have to remember to chain rule the t squared minus 2t, which gives you the 2t minus 2 to go on top. And you'll get 1 point for correctly writing the derivative, which is right here. And then your next point comes from correctly writing the interval. So make sure that you write your less than or equal to sign right here, and then it's just less than 1.
For t is greater than or equal to 0 and less than or equal to 8, find all times t during which the two particles travel in the same direction.
In part A, we found the critical number of VPT by setting the equation equal to 0, and that was 1. And then we set VQT, we found the critical numbers by setting it to 0, which is 3 and 5. And then we did a sign chart. VPT is 1, and then when you plug it in, it's negative on the 1 and then positive, so it proves it's a critical number. And then VQT, we see it's positive, negative, and then positive. And we're asked to find when they're moving in the same direction. So, and since this is the first derivative, we can see that it's moving in the same direction. So particles P and Q are moving in the same direction for 1 is less than T is less than 3, and 5 is less than T or less than or equal to 8, because it is bounded from 0 to 8, and they have the same sign on these intervals right here.
So a common mistake for this problem is that students don't realize that they already gave you the velocity function, so they'll take the derivative of the velocity function and then set that equation equal to 0 to find the critical numbers, which would therefore throw your whole intervals off, giving you a wrong answer. And then another mistake is that students might not realize that you have to use what you did in part A to find the correct intervals, and they might use 0 and put 0 is less than T, which is less than 3. And they might not realize the end part of the interval because they gave you that you're going to work from 0 to 8, and they might do 5 is less than T, which is less than infinity.
Part C. Find the acceleration of particle Q at time t equals 2. Is the speed of particle Q increasing, decreasing, or neither at time t equals 2? Explain your reasoning. So, since we find the acceleration of particle Q at time equals 2, we use the derivative of the velocity equation, and that gives us 2t minus 8. So, at time equals 2, we plug in 2, and we also plug it in this equation, and this would be 4 minus 8 is equal to negative 4. So, since the acceleration is less than 0, that means the acceleration is negative, which means it's going in the opposite direction. So the speed of the particle is decreasing, since originally it was going this way, but now it's slowing down and starting to go this way.
Part D. Find the position of particle Q the first time it changes direction.
For part D, we're supposed to find the position of particle Q at the first time it changes direction. So we used the velocity of particle Q and found an integral of that because the integral of velocity is position. So by doing this, we found that it was t cubed over 3 minus 4t squared plus 15t plus c. And then from the original problem, it gave us that at time 0, the position of particle Q was 5. So we plugged in 5 equals 0 for t, and then we solved for c for 5. And then that gives us the full equation for the position of particle Q. And from part B, that's when we found the first time that the particle Q changes direction, which was at time 3. So we plugged in 3 for t and then solved and found the position of particle Q at 3 is 23.